All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, guys, quickly let me know in the chats if I'm perfectly audible, visible to each and every single student, okay? Everyone means everyone. Let me know in the chats if I'm perfectly audible, visible to each and every single student. Come on, guys, quickly in the chats. Quickly in the chats. Let me know if I'm perfectly audible. Okay. So we are starting the new series. That's the level up series. Okay. Each and every single thing will be from the scratch. Okay. Doesn't matter if you have studied anything before, because we will be starting every single thing from the scratch. So in physics, particularly, I am starting with the chapter that is kinematics. I'm starting with the chapter that is kinematics. Okay. I will be starting from the scratch. I will be starting from the scratch. Now, guys, with this particular series, definitely you are going to love it. Okay. And we will be basically taking 3 to 4 sessions in a particular chapter. We'll be taking I would say 3 to 4 chapters in a particular chapter. Yes. So guys, this is the first session that we have. Let's begin with this session. Okay. Let's directly move on to the topic. Now, guys, we are starting the chapter kinematics. We are starting the chapter kinematics. Okay. Now, my dear friends, first and the foremost thing, what is this kinematics 1D? What do we have to study? It is basically, I would say, study of motion. Study of motion. We have to study, we have to learn about motion. Like, I would say after some time, this car is in motion, this car is moving. Sir, what is the velocity of the car after some time? I might ask you, what is the acceleration of the car? How much time it is going to take from this point to this point? What will be the displacement of the car? So all the questions will be related to motion. All the questions will be related to motion. So kinematics 1D is only the study of motion, as simple as that. Kinematics 1D is only the study of motion. Okay. Now, my dear friends, in this particular case, the very first thing, the very first topic that we need to talk about is, we say frame of reference and observer. Okay. Frame of reference and observer, that is what we are supposed to study. That is what we are supposed to talk about. Okay. Now, guys, listen carefully. Everybody out there, see. What does this frame of reference actually mean? Let's suppose I have got a car. And this car is at, this is the point A, let's suppose over here. I am saying this car is at, I would say 10 meter distance. This car is at 10 meter distance. And I would say here it is point B. I would say, what is the distance of the car? What is the position of the car? How far is the car? You would be saying in this particular case, this car is at 12 meter distance. Now, guys, if I say, which one is correct? Is the car at 10 meters or is the car at, I would say, 12 meters? Here in this particular case, if I say with respect to A, with respect to A. What I can say, car is at 10 meters. Car is, how far is the car? That is 10 meters. Similarly, if I say with respect to B, with respect to B, we say car is at 12 meters. Now both are correct in this particular case. So it completely depends upon which one you are taking as the frame of reference. If you are taking this A as frame of reference, then in that case, car is at 10 meters. If you are taking this frame of reference B, then car is at 12-meter distance. So this is how we define the frame of reference. Frame of reference is with respect to what we are talking about. Frame of reference is with respect to what we are talking about or observing, with respect to which point we are defining the position, velocity, whatever it may be. That is called the frame of reference. Now guys, let's talk about the observer. I'll be writing over here. Observer. Sir, what does this observer actually mean? See guys, let's suppose I say we have got a car over here. Okay, this is the car that we have. Yes. Now inside this car, you have two people. This is A, and there is another person over here, that is B. A and B. There are two people inside the car, A and B. And there is another person over here on the surface of Earth. And this is the person C. Okay, this is the person at rest. And if I say this car over here, if I say this car is in motion, it has some velocity V, it is in motion. Now in this particular case, my dear friends, listen to me very carefully. When I ask this person A, is this B at rest or B is in the motion? I ask this person A. A is saying B is just sitting next to me. I can speak to him, I can talk to him. He is absolutely at rest. So we say according to A, we say B is at rest. So basically when A is observing the situation, according to him, B is at rest. But when I ask the same question to C, C is saying this car is moving. And inside this moving car, you have person A, you have person B. So B is obviously in motion. So according to C, we say B is in motion. Which one is correct? I would say both are correct in this particular case. I say both are correct. Depending upon the observer. Both are correct depending upon the observer. Okay. So if you consider C as observer, then in that particular case, B is in motion. If you consider B as observer, then in that particular case, A is at rest. So observer means the one who is observing the situation. So I would write over here, the one who observes the situation. Observer is the one who observes the situation. Tell me in the chats, is this clear till over here? Tell me, guys. Is this clear? Yes. Now, guys, let's move on to the next one. That is what we call the position. How do you define the position of object? Position simply means it is the location of an object. Location means where the object actually is. It is the location of an object. Where the object actually is, that is the location of an object. Like if I say this is the car over here, okay, and this is the tree. This is the tree. Sir, can we consider this tree as a frame of reference? Yes, we can consider. Now, if I say, with respect to the tree, this car is at x is equal to 10 meters. With respect to the tree, this car is at x is equal to 10 meters. With respect to the tree, the car is at x is equal to 10 meters. Now, guys, listen to me very carefully. Listen to me very carefully. Can I say the position of the car with respect to the tree is 10 meters. So with respect to the tree, what is the position of the car? How far it is? It is at 10 meters. So position means where the object actually is. So that's why I'm mentioning over here. It is the location of an object with respect to the frame of reference. Frame of reference. It is the location of an object with respect to the frame of reference. That is what we call the position. Like over here, with respect to this tree, its position is 10 meters. With respect to something else, we say its location may be something else, its position may be something else. Okay? Okay? I hope this concept is also crystalline clear. I hope this concept is also clear. Okay? Now, guys, can I write a statement over here? Can I write a statement over here? What is that? I'll write a statement over here. If the position is changing, with respect to time, if the position of an object is changing with respect to time, then object is said to be in motion. Then what we can say, object is said to be in motion. If the position of an object is changing with respect to time, like guys, if I say initially my position was at x is equal to 10, then it is at x is equal to 12, then x is equal to 14, so it means the object is in motion, object is moving. Okay? So what I can write over here, if the position remains constant. Constant means if the object is at x is equal to 10 meters, it will remain there only at x is equal to 10. If the position remains constant, then object is said to be at rest, then in that case, object is said to be at rest. In that case, object is said to be at rest. Okay, I hope this is also clear. Okay. Now guys, one-dimensional motion. There are types of motion. First one is 1D motion, like we are studying kinematics 1D. Here we study 1D motion. What does 1D motion actually mean? It means if an object only changes one of its coordinates, if an object changes only one of its coordinates, then object is said to be, then object is performing 1D motion. What does that mean? See guys. If I say this is the car, this car is moving something like this. Can I say in this particular case, this car is moving along x-axis only? So the position of the car here is x is equal to 1 meters. Position of the car here x is equal to 2 meters. Position of the car here x is equal to 3 meters. Okay. So can I not say in this particular case, car is moving along x only? Car is moving along x only. Okay. So here only x coordinate is changing. Y coordinate of the car is not changing. See, x is 1, x is 2, x is 3. Let's suppose if an object is released from certain height, it falls down. So we say only y coordinate is changing. Here y is equal to, let's suppose 5. Here y is equal to 4. Here y is equal to 3. So it is also 1D motion. Why? Because only y coordinate is changing. In this particular case, only x is changing. It is not going like this in a projectile motion, something like that, because that is a two-dimensional motion. So in one-dimensional motion, only one of the coordinates of the object are changing. Either it can be x, or it can be y or z. Then you have got, and in this case, it is a motion along straight line. Okay, like along x-axis only, keep that thing in your mind. Then two-dimensional motion. So here, two of the coordinates of a body are changing. Here, two of the coordinates of a body are changing. In this particular case, here, two of the coordinates of a body are changing. Okay. Like, my dear friends, let's suppose if I say we have launched an object. This is y and this is x. We have launched an object something like this. Now, my dear NEET aspirants, in this particular case, let's suppose when the object is exactly at this point. Guys, smash the like button if you have not liked the session yet. When the object is at this point, okay, can I say this is the distance covered along x-axis? This is how much it has moved in x-axis. This is the distance covered in y-axis. So this is the displacement in y and this is the displacement in x. This is the displacement in x and this is the displacement in y in this particular case. Okay. So if an object in this particular case is moving something like this, means it is moving along x also, it is moving along y also. So this is called two-dimensional motion. An example in this particular case is projectile motion. Projectile motion. Like you have thrown an object and it follows this path and falls down. And it falls down. Okay. Then guys, we have three-dimensional motion. What does three-dimensional motion actually mean? We say here, three of the coordinates of a body are changing. Here, three of the coordinates of a body are changing. So means in this case, here, body moves in x, y, and z. Guys, see. If the object moves something like this, it is only moving in the x-axis. So means one-dimensional motion. Okay. Okay. If I say object is moving something like this, it is a two-dimensional motion. Body is moving along x, body is moving as well as in y. So it is going forward as well as it is going upward also. Then if I say object is moving something like this, something like this, something like this, something like this, it is moving forward also, it is going upward also, it is coming out also. Because when you define x, y, and z, this is x, this is z, and this is y. So it is like an object is coming out, as well as it is going forward, as well as it is going upward, as well as it is coming outward also. That is what we call the three-dimensional motion. Example is flying kite. Okay, or plane. This is also the example of three-dimensional motion. Now tell me guys, is this crystalline clear? Tell me quickly. Tell me quickly in the chats, is this crystalline clear? Okay. Now guys, take a look. Take a look. We have an important topic, that is what we call distance and displacement. That is what we call distance and displacement. Listen to me very carefully. What does this distance and displacement actually mean? See, in this particular case, what I can say over here, it is a two-dimensional. See. Why? Because this is x, this is y. So means you are moving in x as well as y. You can consider this x, this y, and this will be z. Okay. Now guys, take a look. Distance and displacement. What does distance and displacement actually mean? What does distance and displacement actually mean? Let's suppose you are standing at this point A. You are supposed to go to point B. From A to B, you are supposed to move. From A to B, you are supposed to move. When you move from A point to B point, my dear friends, you have two paths. First one is this. Second one is this. Okay? Or this is not the path. Let's suppose this is the path that you are supposed to move. So means the length of this path is 15 meters. If you are moving from A to B, could you please tell me how much distance you are covering? You are covering how much? 15 meters. How much you are covering? 15 meters. From A point to B point, you are covering how much? That is 15 meters. But when you join this A point and B point, when you join A point and B point, in that particular case, what I can say, sir, this distance is the shortest distance between A and B, and its distance is only 10 meters. And if you compare this and this does not have a proper direction, like here direction is this, here direction is this, here direction is downward. So it does not have a proper direction, but it has unique direction. Direction, it is towards B. So means this is also the distance. This is also the distance. What is the difference between upper distance and lower distance? This means this upper one. This is the actual path covered. This is the shortest path covered. We call this as distance. We call this as displacement. This is the difference between the two. So we can say in this particular case, this is the distance and this is the displacement. How do you define the distance? It is how far you have moved. How far you have moved. How long you have moved. What is the actual path length covered? What is the actual path length covered? And when I say displacement, it is how much you have displaced. So my dear friends, if you take a look from this point to this point, can I say this is how much you have displaced? That is only 10 meters. So displacement in this case is 10 meters. How much you have displaced from the original point. Okay. And distance is how far you have moved. That is the actual path length. And this is how much you have displaced from your original point, initial point. That's the difference between the two. Okay. It is the actual path covered. And it is the shortest path between 2 points. Even if you draw few more lengths over here, few more paths over here, let's suppose this one, you'll find that there is only one distance which is the shortest. And that is this one. And that is this one. Okay. And this one is what we call the displacement. Displacement is the shortest point between the 2 points. Distance is the actual path covered. Okay. So it is the shortest path between 2 points. It has a proper direction. That's what I was saying. From A point to B point, it has a unique direction. It is pointing towards B. So it does not have a proper direction. It is a scalar quantity. Distance is scalar. It is always positive. Okay. So we say it has a proper direction and it is a vector quantity. Displacement is a vector, but distance is a scalar. Okay. If particle moves along a straight line, then distance and displacement both are same. Yes, both are same. Both are same. Okay. It cannot decrease with time. Distance cannot decrease with time. But when it comes to the displacement, it can decrease with time. Let me show you how. See guys. Let's suppose you are at point A. You are moving. You reached over here. Okay. This point B. Or I would say you are at point A. You are moving, and finally you reach point A. So you are starting from point A. You have reached point A. Let's suppose you have covered 200 kilometers. In this particular case, what is the actual path that you have covered? That is this one. So what I can say, that is distance will be 200 meters. Distance in this case is 200 meters. And what is the displacement over here? Displacement is 0. Displacement is 0. Why? Because you have finally reached the same point. It is the distance between the initial point and final point, the shortest distance between initial and final. If initial and final point are same, in that particular case, displacement will be 0. Like, let's suppose this is the origin, x is equal to 0 over here. If the car is moving something like this towards right, so car is at x is equal to 10 meters. How much is the distance? 10. How much is the displacement? 10. Now, when the car turns back, car reaches over here. So it is x is equal to 5. So this is 5 meters over here. So what I can say, this is 5 meters. X is equal to 5 over. Now, if the car has moved from 0 to this, so how much distance it has covered? 10. Then again it has reached this point. How much distance it has covered? 10 plus 5 is 15. In this particular case, distance is 15 meters. If I say displacement, guys, displacement is the distance between initial point and final point. That is only 5. That's what I was saying. Displacement can decrease, but distance cannot decrease. Is this clear? Is this clear, guys? Tell me. Tell me. So here it is mentioned that it cannot decrease with time. Okay. It cannot be negative. It cannot decrease with time. It cannot be negative. Distance is always positive. It can decrease with time. It can be negative, it can be positive, it can be 0 also. It can be positive, it can be negative, it can be 0 also. That is the displacement and that is the distance. This is the difference between the two. Let's suppose, my dear friends, you are given a question over here. Find the displacement in each case. Let's suppose you are moving from A to B, from B to C. In this case, if I say, what is the distance covered? You say simply distance is 4 plus 3. That will be 7 meters. 4 plus 3 is 7. If I say what is the displacement? Displacement is also 7 meters. Because from A to B, if you join, it will come out to be 7. So if the body is moving along a straight line, in that particular case, whatever is the value of displacement, same will be the value of distance. Tell me over here. Body is moving from A point to B point. Then is moving from A to C. If I write distance, distance is simply actual path covered. That is 4 plus 3. That will be 7 meters. And if I say distance, displacement. Displacement means distance between initial point and final point. Okay. So total is 4. This is 3. 4 minus 3. This is 1 meter. Displacement in this case is 1 meters. As simple as that. Now, guys, if I say, what is the displacement covered? Okay, one more important point. One more important point I just want to say over here. When I say displacement, displacement is final position minus initial position. We can find displacement like this also. Final position minus initial position. See, guys. Let's suppose object is initially at rest. Object is initially at x is equal to 0. Okay. Here it is x is equal to 1. Here it is x is equal to 2. Here it is x is equal to 3. Here it is x is equal to 4. Let's suppose object has started from x is equal to 2 to x is equal to 4. What is the initial position? X is equal to 2. What is the final position? X is equal to 4. So if I say displacement in this case, what will you say? Final position minus initial position. So if I say displacement in this case, what is final position? Final position is 4 minus. What is the initial position? That is 2. 4 minus 2 is 2. That is the displacement. So that's what I was saying. Initial point and final point. Join the two. That is going to be the displacement. Now come over here. In this case, you have to tell me the displacement. Guys, see. Initially, the point object was at x is equal to minus 7. So here, this is the origin. From the left side, it is minus 7, minus 2. Then object is moving from A point to this point. So means from minus 7 to minus 3. Minus 7 to 3. Then object goes back. It reaches here origin. Then object comes forward. It reaches this x is equal to 7. Then object goes back and this is the point B, final point, that is x is equal to minus 2. In this particular case, if I say what is the displacement, what will you say? Final position minus initial position. What is the final position here? Guys, that is minus 2. Minus 2 minus. What is the initial position? That is minus 7. So this will be minus 7. Minus into minus is plus. This would be 7 minus 2. That is going to be 5 meters. Is this clear? And if you ask me what is the distance in this case, distance is simply you have to add. So this distance, so means this is from here to here it is 7. 7 plus 3 is 10. This is 10. 10 plus 3 is 13. 13 plus 7 plus this 7 plus this 2. That is going to be the total distance. Is this clear, guys? Is this clear? Is this clear? Let's suppose you have this question. Find the displacement between A and B. Okay, find the displacement. Oh, sir, what is the distance? First, you tell me the distance. Distance is going to be 8 plus 2 plus 8 plus 4 plus 8 plus 1. This is the distance. Sir, what is the displacement? See, guys, displacement between A and B is join initial and final point. This is the displacement. Now, guys, see, listen carefully. Listen carefully. Listen carefully. In this particular case, when it comes to the displacement, we say draw a line over here, draw a line over here. What will be the length of this line? See, guys, take a look. Can I not say if this is 8, this is also 8. So from here to here, it is 8. So this was also 8. So total, could you please tell me, this is 8 plus 8 plus 8, that is 24. 24. And how much is this? So first it would be this 1, then this 4, and then this 2, this 2. So 4 plus 2 is 6 plus 1 is 7. So this is 7 meters. Height is 7. So base is 24. Height is 7. Could you please tell me hypotenuse? That is the displacement. So I would say displacement in this case will be, that is the hypotenuse, that is under root of, how do we find the hypotenuse? Base square plus perpendicular square, 24 whole square plus we say 7 square. Oh, is this clear? Tell me. Is this crystalline clear? Okay. Okay. So this is going to be 25. Okay. So guys, this was our first session for this. So that's all for today. See you guys in the next session. Okay. So that's all for today. Thank you. Next session will be big. Okay. So that we can cover each and every single thing. That's all for today. Take care and bye-bye. Thank you. Chalo guys, take care.